Okay, welcome to chapter 4. This is on area measurement. So we're going to be calculating throughout this chapter the area of different objects, of different things. Okay, an area is a two-dimensional measurement. Okay, deals usually with length times width in terms of rectangles, squares, parallelograms. Okay, there's different formulas for triangles, for calculating the area of a circle, a trapezoid, pentagon, hexagon, that kind of thing. We're going to be exploring all sorts of different shapes and different problems concerning area. So let's do the getting started. First of all, we need to know about units. So let's do a couple of the try these here. Let's do a 3 squared. You can see it's 3 to the exponent of 2. So you can see that we have exponents here. All that means is you take that number and you multiply it by itself, by how many times the exponent is. So 3 squared is 3 times 3, which is equal to 9. 6 squared is just 6 times 6, which is equal to 36. 15 squared is 15 times 15, which is equal to, well, that's not one of those ones that somebody readily memorizes, so we can take our calculator. And we can do 15 times 15, and we get 225. And then 2.7 squared is just 2.7 times 2.7, which is equal to, well, let's take our calculator again. And let's do 2.7. And we can also do squared. You can see I've got a squared button right there. And I get 7.29. Okay, so depending on your calculator, you might have one or two buttons that you can use to square or cube a number. So you have to get to know your calculator. Let's use mental math for these next four. Okay, so 0.02 times 10, well, we're multiplying by base 10, 10, 100, 1,000. All we have to do, just like we did a couple chapters ago in the metric system, is that we just move the decimal point. So we're multiplying by 10, we're making the number bigger, so that means we're moving the decimal point to the right one space. So 0.02 times 10 is just equal to 0.20. 0.8 times 100, we move the decimal point 2 times to the right to make it bigger. 1, 2, so 0.8 times 100 is just 80. 3.14 times 1,000, we're moving the decimal point 3 times to the right. 1, 2, 3, we add a little 0 there, so we get 3,140. And 7.45 times 10,000, we're going to move it 4 places because we have 4 zeros. So there's 1, there's 2, 3, 4, 2 little loops without a 0. So it's going to be 74500, 74,500. Okay, not too difficult. When we're talking about area, sometimes we just need to estimate. So there's a little trick to estimating. 5.16 times 40, well, we can round the 5.16 down to 5, multiply that by 40, and it says about, so our answer is not going to be exact unless we use our calculator. So 5 times 40 is 200. It'll be a little bit more than 200, but it's approximately 200. 2.8 times 4.1, well, that'd be similar to saying 3 times 4, okay, which is approximately 12. 12 times 3.7, well, that could be the same as 12 times 4. It'll be a little bit less than 12 times 4, but 12 times 4 is 48, so it's actually about 48, a little bit less. 105 times 3.5, well, we can say that's the same as 105 times 4, or we could even say 100 times 4, round the 105 down to 100, and we could say it's close to 400. Okay, that's kind of how you estimate. If you're in a hurry and you don't have time to get an exact answer, or you don't have a calculator available. Okay, let's look at the hints over here. Multiplying by 1/2 is the same as dividing by 2. That's important to know. Okay, and also check to see if your calculator has order of operations. Order of operations is just BEDMAS, which you've learned from junior high. BEDMAS is an acronym. It stands for brackets, exponents, division, multiplication, addition, and subtraction. You have to do those order of operations when you're multiplying or when you're doing calculations with multiple steps inside. Your calculator usually does it automatically. So for example, in the first one, 4 times 8 plus 5, you have to add 8 plus 5 first. So this is the same as 4 times, and 8 plus 5 is 13, which is equal to 4 times 13 is 52. Okay, B, 1/2 times 5.3 plus 10.7, or it's the same as, we go by this little hint over here, it's if you add 5.3 plus 10.7 in brackets, because the B stands for brackets, we have to do that first. Brackets, exponents, division, multiplication, addition, subtraction. Add these two together, and then multiply it by half or divide by 2. So we can get our calculator out. So we can do 1/2 is the same as 1 divided by 2, or 0.5. And we want to multiply that by, and we can put our own brackets in if you've got this kind of a calculator, 5.3 plus 10.7, close the bracket. So what you see up on my calculator is exactly the same as the question, and hit enter, and I get the answer of 8. Okay? See if you can do C and D on your own. Order of operations. See if your calculator can figure it out, or if you've got brackets, you can put them in. Number 5, express each linear measurement in the units shown. So 12 yards is equal to how many feet? Well, we know from our conversion tables that there's 3 feet in a yard, so 12 yards is 12 times 3, which is 36 feet. B, 210 millimeters. Again, we're talking metric. SI, this is base 10. 210 millimeters equals how many meters? Well, we're going from a smaller to a larger, which means we're going to move the decimal point to the left. There's 1,000 millimeters in a meter, so we're moving it 3 places. 1, 2, 3. So 210 millimeters is 0.210 meters. 18 inches equals how many feet? Well, we know there's 12 inches in a foot. Okay, so we can just take 18 divided by 12 and we can get a decimal. Or we can say it's 1 foot and 6 remaining 6 12ths feet. Well, we know the fraction 6 over 12 is the same as a half. So we could actually say that 18 inches is the same as 1.5 feet. 17 inches equals how many centimeters? Well, we might have to convert that. We know that there are 2.54 centimeters an inch, so we could take 17, multiply that by 2.54, get our calculator out. You've got, in the back of your book, you've got conversion tables, you've got formulas, you can use that. So let's take 17, multiply it by 2.54, and 17 inches is the same as 43.18 centimeters. 43.18 centimeters. Okay, let's talk about height of an object. It says draw a height in number 6 in each 2D two-dimensional shape. You may use any side as the base. Use a square corner to show that the height is perpendicular to the base. Okay, so we're talking about the height of an object. By definition, it's the perpendicular distance. Perpendicular means a right angle, 90 degrees, from the base of the polygon to an opposite vertex. Okay, so let's do this triangle. The height is from the base, 90 degrees up to the vertex. So we're going to say that that's our vertex. So all I'm going to do is take a ruler, I'm going to go down 90 degrees so that this is a right angle on both sides, and this would be the height of our triangle. Okay, I can pick any vertex that I want. I could choose that one or I could choose that one. It doesn't really matter. For B, I've got a trapezoid. Okay, so I have the base. I'm going to assume that this is the base here, the longest side, and I want to go from the base 90 degrees straight up to a vertex. There's a vertex there, there's a vertex there. So I want to go exactly 90 degrees so that this is perpendicular, a 90-degree angle there, and now this would be the height of my trapezoid. Okay, so we need to know the heights of triangle and a trapezoid when we're calculating area, because those heights are in the formulas. Okay, so remember, the word perpendicular means two lines that form a right angle. Okay, all right. Number 7. Match each name with the best diagram. Well, parallelogram. Well, parallelogram by the name means that some sides have to be parallel to each other. If you look at object A, B, C, and D, the best one that fits a parallelogram would be that one right there, because this side here and that side there are parallel, and that side there and that side there are parallel, so I would say that it would be D. A square. Well, There's our square right there. It's just turned on its side to look like a baseball diamond, but it's still a square. So I'd say the best one, because we want the best diagram, would be B. Trapezoid. Well, trapezoid could be A and E, but the best trapezoid is probably E right there. Okay, so I'm going to say it's going to be E. And a pentagon, penta means 5. Okay, so which object has 5 sides? Well, it might be this one right here. 1, 2, 3, 4, and 5. So that would be C. That is a pentagon. Okay, 8. Match each formula with the best diagram. Now, you don't have to memorize formulas because you have formulas at the back of your book. You can use them. Maybe your teacher will give you a formula sheet for a test or a quiz. You don't have to memorize these formulas, but you just have to know how they're used and how to do the calculations in them. So, let's match them. Area of a rectangle. Well, which one over here looks like a rectangle? I'm thinking right there, P. And the area of that rectangle is just the base times the height. Area of a triangle, well, I've only got one object over here that looks like a triangle. That would be the object O. Notice that the formula for the area of a triangle is 1/2 base times height, or base times height divided by 2. And the height of the triangle, you can see, is 90-degree perpendicular line from the base up to the vertex, just like we did on the last page. Area of a parallelogram is base times the height. Well, which object is our parallelogram? That would be this one right here. Okay, there's our parallelogram, but notice that the height is right here. Okay, it's not the length of the side here, it's not that dimension right there. It has to be 90-degree perpendicular from the base up to a vertex, okay? So that would be M. Area of a circle, well, we've only got one diagram that has a circle. You can see it's pi times the radius squared, or pi r squared, so that would be N. And area of a trapezoid. We only have one left, that would be Q. But I want you to notice that it has the height in there. It's the base plus the opposite side, so it's whatever the base dimension is, plus the opposite side, which is this one right here. You add those two together, divide that number by 2, and then multiply it by the height. And the height, again, is 90 degrees from that base there to the vertex. Okay? Number 9, calculate and round your answer to 1 decimal place. Well, pi times 7 is the same as 3 divided by, or pi divided by 7 is 3.14 approximately divided by 7. So you take your calculator out. But you'll notice that on my calculator I have pi. I hit second function, and I've got pi above this arrow, so you can see there's my symbol pi. And it says divide that by 7, and it says round to 1 decimal place. So it's 0.4487. I want to round to 1 decimal place, so my second digit is a 4, so I'm going to keep it at 0.4. Pi times 9 squared, well, that's the same as pi times 9 times 9. So I'll take my second function pi, I'll multiply it by 9, and I'm going to hit my squared button right there. Pi times 9 squared is equal to 254.46. I've got decimal 46. My second digit is a 6. It's larger than a 5. I'm going to round up, so it's going to be 254.5. 254.5. Pi times 1.3 squared. Okay, let's do second function pi. Multiply that by 1.3 squared. And I get 5.309, so it just rounds to 5.3. And pi times 10.5 squared minus 8.1. Okay, so let's just put it in the way it shows it, and let's just see if our calculator does order of operations. Pi times 10.5 squared minus 8.1. I get an answer of 338.26. We need to round to the nearest tenth. It's 338.3. 338.3. Now, I didn't put any brackets in this one at all. Let's just see if we get the same answer, 338.3, if I do the brackets. So I'll take second function pi. I'm going to multiply that by, and then I'm going to put in 10.5 squared minus 8.1. 10.5 squared minus 8.1. And I get a different answer. So obviously, order of operations doesn't work on this calculator, okay? Or it depends on what the calculator, how the calculator reads it. So it might be second function pi. Let's do a bracket. Let's do a bracket. Second function pi times 10.5 squared, close the bracket, and then let's minus 8.1, and we get 338.3. So that's kind of how it did it. It did the multiplication first, and then it did the subtraction later. Okay, so 338.3 is our correct answer because it's going to follow BEDMAS, brackets, exponents, division, multiplication, subtraction. So it did this first, and then it subtracted 8.1. Okay, so your calculator is set to do order of operations. Match each net with a sketch of its 3D object. Let's look at what a net is. All a net is, it's a composite 2D shape that can be folded to create 3D objects such as a cube, a cone, a pyramid, or a cylinder. You're probably going to do examples like this with your teacher, be given some paper, a ruler, some scissors. You're going to be cutting out objects and you're going to be taping them together just to see how you can unfold them and what they look like. Okay, so we're going to match them. So let's do the first one right here. This first one right here looks like it might be something like a Kleenex box if we were to cut the sides and fold it open. At least that's the way I think. So I'm thinking that this one looks like that. That's the net of this object right here. This one right here, number 2, I'm thinking because it's got a round top and a round bottom, I'm thinking it's got to be this cylinder right here, kind of like a soup can. So if I was to cut around there, open it up like a can of soup on both sides, this is what I would end up with, and fold it out. This next one right here, I'm thinking it looks, if I was to open it up and fold it, it looks very much like this prism right here. Okay? So that's the introduction to Chapter 4 on measurement of area. Okay, so we're going to go on to 2.1.